Welcome to the Accomplished Brain podcast, where we share our passion, knowledge, and experience about the brain and health.
First, to just look at the evidence-based therapies, I mean, that stuff's pretty obvious, right? It's like, if somebody's done a study on something of a methodology that's proven, right? For example, like Cymbalta helps with anxiety, and there's been tons of studies on stuff like that, right? When, as in Andrew and I's world, we look at that as, well, if we have somebody with anxiety and we know the anterior cingulate has a lot to do with our shifting thoughts, how can we give the anterior cingulate support in order to help that anxiety? And so when you think of a mechanism based, right, such as that, and first of all, a mechanism is defined as a system of working parts working together in a machine or an established process that brings about a result. And so when we think about that from neurological rehab, right, we know that left side cerebellum is going to interact with our right side cortex, right? We know that horizontal tracking is going to stimulate not only our temporal lobe, but also our pons, right, in our brainstem. So
if it's a heart, right,
if it's a horizontal tracking.
right.
So we can take these things that, like, well, we know the pathology or we know the mechanism, so why wouldn't that work? And I think we're learning so much so rapidly about the brain, about neuroscience, about pathology, that the studies, right, haven't caught up to how quickly or how deep the brain is. And I think that's one thing that Andrew's done an incredible job with the course, and I've been so lucky to be a part of, is that, hey, here's the pathology, like, here's how the functionality is. And so if we can give support to it, if we can activate it, or if we can inhibit it, then we can help create hemisphericity in the brain, or we can create balance, if that makes sense.
Yeah. And I think, Jeff, that was really, really well said. I think exactly what he was saying is, here's the pathology, so here's what you have, and here's the system of how things connect together, and then we're making an observation, or we're making a good how do you say, we're making like a good, I wouldn't say guesstimate. I would say we're making a good logical next step would be, if if you have a pons lesion. Well, here's a better instance. People sometimes have a pontine nuclear, a pons issue. So then you go back and you look at what's in their pons, right? You could say, well, their facial nerve, their cranial nerve 7, right, which is their facial nerve. So muscles of the face. You could say that the sensation of their face, cranial nerve 5, which is the trigeminal nerve. You could say they have their vestibular, so their vestibulocochlear, so that's their cranial nerve 8, right, which is balance and hearing. And so all of a sudden you can have, say, something wrong with their face, their sensation, and then they can have something in their they could have, say, a balance issue, right? So now you're going in and you're saying, well, maybe their pons is affected. Maybe there's no pathology, right? So just say that, you go in there and you look at a CT scan and there's no abnormalities with the structure. There's no tumors. There's no vasculature issues. But we know that those things aren't functioning right. So then you could say, well, maybe the pontine area, right? And then we look at like horizontal. So that's one case, right? We know all those structures, like this is mechanism, lie into the pons. We also know that when you're doing horizontal eye movement, right? If you could trace the eye movement to the abducens nuclei, right? Because we know that's a part of it, right? Again, and that abducens nuclei is located in the pons, right? So you're doing this horizontal tracking. We know it's medial temporal lobe. We also know abducens nuclei. We know the pathway, so we know the pons is affected, and we see that they have trouble with tracking their So if they're tracking to the right and left, their head wants to move. It's a common thing that happens. So we think there's something going on with their vestibulo-ocular reflex, which again, in the pons. So then we know that with the pathways, this is mechanism-based therapy. We know with the pathways that we know, and maybe we can, I think I have it in here, and I'm going to bring this up a little bit, right? So I think we have it in our course. This is going to be really cool. So we're going to bring this up a little bit. So I think when we start looking at this is really.
And Andrew, while you're bringing this up, I just have to say, I think that's one of the biggest aspects of the course is the visual diagrams that you were able to put together in actually seeing the pathologies. I myself am a visual learner, and how well you're able to put together the neuraxis and basically almost like looking like at the pathways that we were talked about last week with neuroplasticity. I think that's a huge way for a practitioner to learn, but it also actually really helps the client kind of understand what you're trying to accomplish from a practical application standpoint.
Yeah. So watch this. And thank you, Jeff. And he's right. We put a lot of time into the diagrams. So if you look at this, right, if you want to track a target to the left, look at this. So if you look up here, you have the eyes, you have the cortex, so you have the left and right, like you're looking at the person. So that left medial temporal lobe will fire down to if you're doing this horizontal eye movement. So if you're doing this tracking to the left, that left medial, look at this. We got this in the course, which is unbelievable. And this is the mechanism. And we want to explain of how doing vertical eye movements could help the pons. This is like I'm through the roof with this explanation. So you have the medial temporal lobe. So you want to take a target. Here's my thumb. Your eye wants to track to the left. Medial temporal lobe will fire down into the green, which is in the pons. The green is in the pons. The orange is the upper brainstem called the mesencephalon, and the blue is the medulla, right? These are all where your cranial nerves sit, and there's a massive amount of function. I'm going to come back to another diagram of how the cranial nerves of the brainstem could affect the memory centers, right? This is just really cool stuff. So you come in and you're tracking a target. The left temporal lobe fires down into the brainstem, right? The adducens nuclei. It stimulates that activates that's going to activate the cranial nerve 6, which again is also, let's follow this pathway, right? Which is going to activate the medial, which is the medial longitudinal fasciculus, which is just a structure in the pons, and that is going to fire to now the upper brainstem, because what happens is when you're tracking your target to your left, one eye is moving lateral and the other eye is moving medial. So the right eye gets activated by an eye muscle called the medial rectus, which that muscle sits into the upper brainstem. So here's a simple thing. Simple thing. We know now that the upper brainstem and the pons communicate with each other. We know that. We could see that right here. We know that they communicate with each other. So with that said, we know that if we strengthen the upper brainstem, you have an issue with the pons, right? And you give them, so you have an issue with the balance. You have an issue with, sensation of the face. So they come in and they do a CAT scan. They go to the neurologist or neurosurgeon. They get a CAT scan. They rule out to making sure that they don't have any vascular issues. They rule out that they don't have a tumor. They rule out there's nothing abnormal with the structure, but they're having something with the function. Like their balance is off. That their eye movement is off, right? All this stuff. You try to give them horizontal eye movement, and that doesn't work. They fatigue, and they just get worse. But we know Here's mechanism-based therapy. We know that just in this picture that the upper brainstem in orange and green communicate with each other. We see it here in the pathway. So we know if they communicate with each other, right? The next logical step is we could give them vertical eye movements or head movements vertically. A lot of times now go back and give them a vertical eye movement or a vertical head movement, and now go back and give them that for a week or 2 weeks. You'll start to see recheck their balance gets better. Recheck to see if their sensation of their face usually will get better. I mean, so again, was that tested and became evidence? No, that hasn't been yet. Maybe that's something that we need to so we have a hypothesis, right? And we said that if you have an issue that you think you have in the pons, and you give exercise in the pons, like horizontal eye movements, that basically people will, might get worse because that area fatigues. And we're going to go over we're going to have a whole podcast on what is fatigue and how to get around that. But now our mechanism is, we know based on this picture in our course, we know that the green, the pons, and orange communicate with each other. Enough said. So now our next logical thing is, let's give them and activate and strengthen the area in orange, because we know green and orange communicate with each other. Almost positive, I've seen all the time, they have an issue in orange, you give them exercises. You have an issue in green, you give them exercise in green, they fatigue. You give them that mechanism, orange and green communicate together, give them exercise. So what would you do? Tracking, head movements, vertical, or tracking vertical. And all of a sudden you go, and a week, 10 days, 2 weeks, a month, whatever the time frame, and you start seeing rechecking their rechecking their horizontal eye movement, rechecking their balance, rechecking their sensation of face. All of it has gotten better. That is mechanism. Now, if you go in and you do a study and you ask, like, say I did a study on that, there might not be no evidence that's out there, but I could tell you that in my practice that I've done that over and over and over and over. And all I have done is, and basically mechanism-based therapies are, I look at the mechanism and I just keep connecting the dots, and I keep thinking logically. I keep saying to myself, okay, I could see that in some instances that in green, the pons, and in orange, the upper brainstem communicate with each other. I could see that I have a problem in green. I give the client exercises in green and they fatigue. We're going to go over a whole podcast on what is fatigue and how to get around that, whether it's nutrition, whether it's going to other areas, because other areas communicate, just in like this example. So then my next logical thing is I can give exercises in orange, because I know that orange and green are gonna communicate with each other. So I know that if I give exercise in orange, green is gonna benefit. And maybe they're gonna benefit at a better rate. Meaning, like, if you lift a weight, and if I go into green, the direct area, it's like lifting a 10-pound weight. But they fatigue. They pick the 10-pound weight. It's too much. Or I alter my form.
Right.
Now, when I go in, I might give exercise in orange. And by the time green gets that stimulation, or green gets that benefit of doing the vertical eye movements in orange, that green, it's like lifting a 5-pound weight. And I'm like, you know what? I can do this. I can lift this 5-pound weight. And I've seen that over and over. Now, that's a mechanism-based therapy, right? Now, that's not something that might be researched, but maybe at some point it could become a hypothesis with a scientist, right? Because I have all these ideas that I see that are working with mechanism. And the next step is to get a greater population of people to accept that is a study to become evidence. But what I want people to recognize is, a lot of times before it becomes an evidence, it became a hypothesis. And before that became an hypothesis, it became a mechanism. Somebody saw a mechanism, and then they started to try to do that. And they saw it worked at a very small scale. And they started to make it work on a little bit of a greater scale. And then they saw it enough to say, we got to get that studied. Let's create the hypothesis. And then that hypothesis became a study, and that study became evidence. And all I'm saying to people is if you're a therapist out there, don't be afraid to dive deeper into the depth of the neurophysiology. Don't be afraid to dive deeper into that. That's one. And then the second thing is, don't be afraid to listen to somebody or explore somebody who's had a lot of things and mechanisms that down the road, some of those things might turn into be evidence, because you could be missing the boat on learning something and being very open to learn that might be able to help your clients or patients dramatically. The second thing I'm going to say is, if you're a patient and you haven't heard, this hasn't become mainstream therapy yet, but you're still went to all these other therapies and you haven't gotten the result that you're looking for, right? And you're looking for something to get better, to improve your function, and you find somebody that does mechanism based and they sound intelligent, and they explain things in a good way, have an open mind, because that therapy might be able to help you out a lot. And then eventually that therapy might become, a hypothesis to a study, and that study might become now an evidence-based therapy. And that's, and I want to bring something up. I want to talk about two more concepts in this. So that was one with using eye movements.